Okay, maintenance came by looking for their bucket. Okay, so how do we get the new theta? Well, we take, if theta is 1.2 and it changes by negative 0.001, then the new theta is going to be 12.2 radians plus the change, which is negative 0.0001 radian, giving us, and I don't know where I got 12.2, it's just 12. So that's going to be 11.9999 radians. In other words, it didn't go hardly anywhere, it didn't change much, but this was only in a millisecond. Okay, now, next thing we need to do is find our change. We want to find our new omega, but before that we can find our change in omega. What do we need to find our change in omega? Well, because definition here and so forth, we need alpha and delta t. Now, unlike when we needed to find our change in theta, we had all we needed in order to find change in theta because we had omega, and that's all we needed with our delta t. To find our change in omega, we need alpha and delta t. So we got to find alpha. So to find delta omega, we need alpha and delta t. Well, we're okay with delta t, but what about alpha? Well, alpha, we don't have it. Okay, what are we going to do? Look around. What do you see? Back in our original conditions, we see that we have a way of calculating alpha if we know theta. Do we know theta? Well, yeah, there it is. Now we're going to use the old theta instead of the new theta. And actually, it's, slightly more complicated technique. We use the old theta and the new theta, and we kind of average them. But in this course, we're not even going to mess with that. That's a fairly easy idea once you understand this, and we don't want to confuse things any more than they're already confused. Okay, so we use the old value of theta. Everything we calculate here, we base on the values at the beginning of this interval. So alpha is going to be negative 300 times the cosine of 1.2, and that's going to be 1.2 radians. Okay? Now 1.2 radians is, cosine of 1.2, that's going to differ by 0.3, so it's going to be pretty close to 0.4. So I'm going to say that you can get the accurate value of this. I'm not going to mess with the calculator and everything. But I don't think I'm far off if I say that this is going to be pretty close to negative 120. Okay? Now, I'll make a note that that's in radians per second, or radians per second squared. But what we're going to do with that is we're going to then, after we get alpha, we're just going to calculate delta omega based on alpha. Okay, so let's come up here now. Okay, so we multiply that out. Negative 120 times 0.001 gives us what? Okay, first of all, why do we do that? Delta omega is alpha delta t. So that's negative 120 radians per second squared times 0.001 seconds. And that comes out negative 0.12 radians per second. Okay, so that's taken care of. Okay, so now, again, where were we? We had theta and we had omega. We wanted to find the new values of omega and theta, meaning we had to find the changes in omega and theta. We used the definition of rate to see that the change in theta is omega delta t, the change in omega is alpha delta t. And we multiply those out, and we think a little bit about what it means, so that starts to sink in. So we can have a little more confidence in what we're doing at each step. We got our delta theta, and now we've got our delta omega. And we used our delta theta with our old theta. We just added the change to what we already had. And we obtained our new value of theta. We do the same with omega. So the new omega equals the existing value of omega, which is negative 0.1 radian per second, plus the change, which is negative 0.12 radian per second. And that gives us negative 0.22 radians per second. What do we do next? Well, now theta equals 11.9999 radians. In other words, it's effectively 12, but we've got to keep all those significant figures. And omega equals negative 0.22 radians per second. So we've moved just a little tiny bit, but we sped up significantly. Well, next, we just do exactly the same thing we did here. We calculate our delta omega. And delta t. Define omega and t after another millisecond or another 0.001 seconds. And I suggest if you aren't really clear on this, and I think not many people would be at this stage, that you calculate that and just follow the calculation scheme over here. But of course now you've got a different value of theta. That's not going to change the cosine by very much, because theta is changed by a minuscule amount. But you might want to use more accurate values when you calculate it. And more significantly, find your new value of omega. Okay? By finding the change in theta and the change in omega. You find the change in theta based on the fact that omega is the rate of change of theta with respect to t, which means this, which means this. And you find the change in omega by the fact that alpha is the rate of change of omega with respect to t, alpha is equal to this, and delta omega is alpha delta t.